All right, folks, I wanted to walk you through the segment addition postulate card sort. There were some interesting, challenging problems in there, so I wanted to talk to you about how to do that algebra, because I know it's been a while. We got to review that. I also wanted to show you what Desmos looks like on my end and what I'm looking at when I'm looking at your work. So we've already came to the conclusion there's no submit button, so you just want to get to the last slide and answer the last slide. I'm currently looking at the first card sort, slide 4 here, and I've anonymized everybody, and what we're seeing here is that some folks, possibly in their groups, decided the right combinations of things, which is very interesting because this was hard, so thank you guys. So when you got it right, the idea is that there would be 4 pairs of cards that are correctly matched, and there are 4 cards that are not being used. So that's the correct way to do this. So if we look at this next person, this person made 2 correct matches, left 2 cards that we shouldn't use alone, and then made 2 matches that didn't work, and then 2 of the cards that were not used weren't supposed to be solo. So I think probably if you grab these 2 cards and match them up with these instead, that would be correct. The thing I want to point out is this person didn't do the card sort. This person didn't do the card sort. Right? So just be aware that it's super weird and kind of creepy. I can see what you're doing. So please make sure you're on it. This person might even have made really good matches, but they ended up matching 3 on 3. And so that was not what we're looking for. So you can't really look at those answers very well. All right, so what I want to do is I want to make sure we look at this slide. And we're going to go through the answers to these using the segment addition postulate. So I'm going to do all of these just to formally have them. So we're going to start with, you know what? No, not. Okay, we're going to order these from sort of simple to more complicated. So the numbers we're not using are these. These are the 2 we need to do on our own. These are the 2s that we did in class together. Okay, so what I'm going to do is, let me see, this is the segment addition card sort. So I'm going to be looking at these diagrams that are off on the left. I'm going to start with this one. So I'm going to be describing what I see in this diagram. I see segment length TU and segment length UV add up to the same as the whole length of the segment from end to end, which is TV. And if you're looking at these, usually the letter that gets double used here can be ignored. So then you should spell TV on this side as well. So I'm going to substitute TU is missing. We put the next here or whatever letter you want. UV is 20 and TV is 32. So the arrows on that segment pointing that way are telling you to go from all the way from this endpoint to this endpoint. So solve for x, solve for TV, we're going to subtract 20. So 32 minus 20 is 12. Okay, so then you grab the 12 card and stack it on top of this one to match it. Okay. So that's the first one. The second one is going to be this one. So this one has multiple parts, that's fine, we just read it slowly. So we got segment ij, whatever that length is, plus the length of jk, and also the length of kl. If you add all 3 of those, you will get this j gets used twice, k gets used twice, so that should give you il, which is the 2 endpoints of the segment. So these lengths should all match up, so these 3 should add up to the length of the long segment. So we've got a 9 and an 11, and a missing kl length, and a 26. So that's a 20. So I'm going to subtract 20 from 26, and I get a 6. And that was the right one. Okay. So let's get into the fancy ones. So fancy I can't see it. All right, okay. So this next one on top, I'm going to sketch that because I haven't really taken the time to read this diagram. I want to make sure I read it. And I know that one of the wrong answers people picked on this one was a number you get most of the way through solving this problem, but not quite at the end. So dx length is 3x minus 28. I'm going to say dE plus EF is 3x minus 30. I'm going to add EF. This is just an x. It's FG. I'm going to add all those, 3x minus 28 plus 3x minus 30. Plus x, and when I'm done, that will give me the entire length of my segment, which is dg. And I've got an extra, and it says so very clearly over here that is 33 long. Okay, so we're going to solve. Now heads up, folks, this is one of the mistakes I think we were making, is we're not solving for x, we are solving for dE. That's the question. How long is dE? I'm going to group like terms. We got 3x plus 3x plus x, that is 7x. We've got a negative 20 and a negative 30, that's a negative 58. I'm going to add 58 to both sides to get a grand total of, that's 33, to 91. And I divide those. I get a 13. I think a lot of you guys picked that 13, but we were supposed to leave the 13 alone. It doesn't go in the piles. What we want to do is find the length of DE. DE is 3 times x, which we just found out is 13, minus 28. And that is 39 minus 28, which is 11. So 11 is the answer for this one. Okay. I think the same thing happened to some of you when you did the last one. Let's see. So last one got real interesting. There's a hint on slide 5. I know some of you definitely checked that out. Let's see if we can use that. So we got BC, CD, which we are not actually finding the length of, and DE. Okay, so the things that I can label here is this is 3x plus 47. Even if I don't use arrows, if this is centered on BC, it's telling me the length of BC. Same thing here, I'm going to put a 10 in the center of DE. And then I'm going to write 2 separate equations, both of which include CD. Right, so CD we got no comment on. All right, so numbers I'm missing right now. B to D, right? That should be, we don't have a number, but 27 plus x. CE, that's x plus 26. So I'm going to write 2 separate expressions. I'm going to ignore this segment for a moment and write down how this adds up. So we have BC plus CD equals BD. And the expression there is 3x plus 47. I've got nothing for C, I'm just going to leave it, equals 27 plus x. I'm going to come back to this. And then I'm going to do the same thing over here. I'm going to ignore this end and write an equation for how this fits together. So I have CD plus DE equals the length CE. So CD is, just leave it. DE is 10, so that's nice and simple. And then CE is x plus 26. So I'm going to be writing 2 separate expressions for CD. That's what I want. I think we're good on slides for now. Okay. So I'm going to simplify these. This one's nice. So CD is equal to, I'm going to take this 10 away from both sides. So it's going to be x plus 26 minus 10, 16. So I'm going to just have this ready to go. I'm going to use it in a moment. Over here, definitely a little messier, but I want to isolate CD. So I'm going to subtract the 47 from both sides. It's going to give me CD equals negative 20. And I'm also going to subtract the 3x from both sides because I really want CD by itself. So it's going to be negative 2x. And the reason this is good or useful is that we now have 2 expressions for CD. So what I'm going to say is I'm going to say negative 20 minus 2x equals CD, but also CD is equal to x plus 16. And what's going to happen here is I can cross over these 2 equal signs and skip the middle, and I can set these 2 equal to each other and solve. It's called using the transitive property. We use that one a lot in geometry. Transitive property is you have 2 equal signs and a thing in the middle that you can now skip and look at the first expression and the last expression and see if it gives you anything. So we're going to do that. I'm going to skip this, see what this tells us. So I'm solving for x. Positive x's are preferred to negative ones, so I'm going to add 2x to both sides. However, we do have a negative 20 left. And this is getting a little ridiculous, but I'm trying to solve for x, so I'm going to move the 16. And divide by 3. And I think, again, some of you got this far. However, maybe we got a little turned around. This is a negative 12. It's not one of the options. It doesn't feel good. Also, generally speaking, lengths can't be negative, but just kind of for informational purposes, this length, CE, that's an x plus 26. If you put the negative 12 in, it won't give you a negative number. That's all right. And then we are not actually finding CD in this problem. We are supposed to find CE. That is our mission. So I think that's where some of you went wrong. So find CE, this one. So to find CE, I've got this expression, x plus 26, and I'm going to substitute what I've got. I got a negative 12 plus 26, which is a 14. And that would be the answer that would work out here.